Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to be talking about the laws of exponents, which is a topic you need to know in order to do your best on the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. More specifically, we're going to start this video by reviewing the 6 laws of exponents. And then in the second half of this video, we'll do a significant number of practice problems. So all that said, let's go ahead and get started with this video. If you're following along at home, I'd advise you to try to take notes as you watch this video. Again, on the ASVAB, you're not allowed to use a calculator or a formula sheet. So you have to know these laws of exponents by heart. That said, hopefully by the time you make it to the end of this video, you'll have a good understanding as to how to use them, and you won't have to refer to a formula sheet at all to do these problems. But that said, let's go ahead and get started. The first exponent rule we're going to look at is the product rule, and it says to multiply when two bases are the same, write the base and add the exponents. Let me go ahead and I'm going to zoom out a little bit so we can see everything clearly. There we go. That should be better. Yep. All right, so again, the product rule says to multiply when two bases are the same, write the base and then add the exponents. So as you can see here, we have x to the m times x to the n, which have the same base of x. In order to do this, since they're multiplied by each other, you simply just add the exponents. So that becomes x to the m plus n. All right, I'm going to go ahead and work out all these examples for you. For this first one, we have x to the third times x to the eighth. And according to the product rule, we write the base of x and then we add the exponents. So 3 plus 8, which of course is 11. All right, let's go ahead and do B. B says, let me go down a little bit. B says 2 to the fourth times 2 squared. As we can see, the base in this case is 2. So according to the product rule, we write down the base first, 2, and then we add the exponent. So that's going to be 4 plus 2. So in other words, this is 2 to the 4 plus 2, which is just 6. Let's go ahead and do C. This one, as we can see, has some parentheses, which is fine. In the first set of parentheses, we have x squared y. And in the second set of parentheses, we have x cubed y to the fourth. All right, so this is the same thing as these two, believe it or not. When you just have two parentheses next to each other, that indicates you multiply. And in this case, you can see that we have two bases. We have the base of x as well as the base of y. That said, as we can see right here, there's no exponent here. Just as a reminder, when there's no exponent, you have to know that there's going to be a 1 there, inasmuch as anything raised to the first power is just itself. So y to the first power is just y, which is why they left off that 1. Typically, you don't express 1 in mathematics. So let's see. So in this case, we're going to deal with the base of x first. So I'm going to write that down. And you can see I have x squared times x to the third. According to the product rule, I simply just add their exponents. So this becomes x2 plus 3. And then here we have the base of y. So let's write that down. As I mentioned, this one's raised to the first power. This one's raised to the fourth power. So according to the product rule, we just add them. So that's going to be 1 plus 4. And let's go ahead and simplify. X to the 2 plus 3 is x to the fifth. And y to the 1 plus 4 is y to the fifth. Okay, so that's all there is to the product rule. Write down the base, add the exponents. And the hardest part about today's video is going to be adding all these concepts together. But that said, by the time we get there, you should know these laws of the exponents well enough to where that's not going to bother you too much. But that said, let's go ahead and move my blank sheet here. All right, so now we're going to do the opposite of the product rule, and I'm going to zoom in a little bit. I know I get a lot of viewers who are using cell phones, so let me just make sure that they can see exactly what I'm doing. All right, that should be a little better. All right, the quotient rule says to divide when the two bases are the same, write the base and subtract the exponents. So again, in this case, we have x to the m over x to the n. As we can see, the base is x in the numerator as well as the denominator. According to the quotient rule, you start by writing the base, and then you simply subtract the exponents. More specifically, you subtract the top exponent from the bottom exponent. So that becomes m minus n. Pretty straightforward. So let's go ahead and look at a few examples. And I went to the thick pen. Let's go back to the thin pen. This first example says x to the fifth over x squared. According to the quotient rule, we start by writing down the base, which is x. Then we subtract the exponent in the numerator, which is 5, from the exponent in the denominator, which is 2. So this becomes x to the 5 minus 2, which is x to the third. All right, let's move on to example B. As we can see, that is 3 to the fifth over 3 to the third. According to the quotient rule, we start by writing down the base, which as we can see is 3. Then we subtract this top exponent by this bottom exponent, so this becomes 5 minus 3, which is 3 squared. And we can work that out if we wanted to. 3 squared, as we know, is 9. All right, so let's look at C. Again, we're still going to be using the quotient rule to work on this one. We have x squared y to the fifth over x y to the third. All right, in this case, we're not dealing with just one base. As you can see, we have the base of x as well as the base of y, which is fine. We'll just work on those independently. And similarly, we don't see this x down here in the denominator raised to power. In light of that, we have to know that that's going to be raised to the first power, which will enable us to do this. Let's start by looking at the x's. According to the quotient rule, we write down the base, then we subtract the numerator, the exponent in the numerator by the exponent in the denominator. So this is 2 minus 1. We write down y, and then we're going to subtract the exponent in the numerator, notably 5, by the exponent in the denominator, which is 3. So this is 5 minus 3, which is the same as x. 2 minus 1, which is just 1. We're not going to express it because it's raised to the first power. It's just going to be x. And then y, 5 minus 3, which is 2. So that's y squared. Okay, so that was the quotient rule. We are a third of the way done through these exponent rules, and they're not too bad. That said, a lot of people who haven't seen this in a while might panic if they saw this on the test, but again, these are kind of simple questions. If you see something like this on the test, just and you know these exponent rules, it should be almost a guarantee that you're going to get it right. All right. The zero exponent rule says any base except 0 raised to the 0 power is just equal to 1. So x to the 0 power is just 1. Y to the 0 power is just 1. 6 to the 0 power is just 1. Sorry about that. I wanted to erase that marker I made. Y to the 0 power is just 1. 6 to the 0 power is 1. And All this, which is inside parentheses, raised to the 0 power, is just 1. Again, according to the 0 exponent rule, anything raised to the 0 power is just 1, excluding 0. Again, this does not apply to 0 to the 0 power. Everything else. All right, let's move on to the fourth exponent rule. In my opinion, the first 4 exponent rules are pretty simple. And then the next 2 are going to be slightly more challenging, but it's not going to be anything you can't handle. According to the power rule, to raise a power to another power, write the base and multiply the exponents. So in this case, we have base x to the m power times our raised to the nth power. So in this case, we write our base, x, and then we multiply our exponents instead of adding them. Let me go back to the thin pen. So again, this is the power rule. It says, and this would look like this in case you're wondering, without parentheses, x to the m raised to the nth power. Okay, that's another way to express that in case it's not clear. And in which case we would go x to the m times n. Okay, so again, let's take a look at a few examples here before we move on. We have x to the third squared. Again, this is saying take base x to the third power and square everything. So in light of that, we're going to use the power rule. To start, we're going to write down the base, and then we're going to take this 3 and multiply it by 2. So this becomes x to the 6th. All right, same thing here. Instead of dealing with a base of x, we're actually dealing with a integer. So we have 3 squared raised to the 4th power. According to the power rule, we start by writing down the base, which is 3, and then we multiply the exponent. So this is going to be 2 times 4, which is going to be 3 to the 8th. And finally, let's look at example C. In this case, we have z to the 5th, all raised to the 2nd power, or squared. So according to the quotient rule, we write down the base, which is z in this case. Then we multiply the exponents. So that's going to be 5 times 2, which is z to the 10th. Okay, so pretty straightforward so far. And the more comfortable you become dealing with these laws of exponents, the more likely you are going to be able to solve some of these problems without doing any work. And ultimately, that's the goal. At least half of these problems, if you practice enough, you should be able to solve without doing any work whatsoever. All right, so let's take a look at the expanded power rule. And since there's no definition here, let's look at a few basic examples. The reason there's no definition is because this is simply the power rule. The only thing you have to be mindful of is this is the power rule and it's applied to everything that's in parentheses. In other words, this m is going to apply to the base of x as well as y individually. And let me go back to the small pen. Again, let's rewrite this in a way that we're familiar with. This is the same as x to the first, y to the first, all raised to the m power. If you were just doing this, x to the first to the m, you would be able to solve it with the power rule by writing down the base x and then multiplying the exponents 1 times m. It's the same thing here. You're just doing that for everything where this m applies to. So again, I'm going to do x. I'm going to write down the base x. I'm going to do 1 times m. I did the power rule between x to the first and m. And now I'm going to apply the power rule to this y as well. So this is going to be y 1 times m. And if we simplify this, this is x. Anything times 1 is itself, so that's just m. And again, anything times 1 is itself, so this is just m. It's basically like distributing this power to these bases via the power rule. Okay, so that's all it is. It's just a more complicated version of the power rule. So let's take a look at this example real quick. As we can see, we have a fraction in this case, but that said, because of the expanded power rule, we know that this power of m is going to apply to x as well as y. And let me rewrite this such that it's easier to see. Again, we can write that as x to the first, y to the first. This is all raised to the m. And what this says is we're going to take the power rule, apply it to everything in parentheses, starting with x, and we're going to write down x first, and that's going to be 1 times m over base y, 1 times m. Anything times 1 is itself, so this is x to the m over y to the m. Pretty straightforward. It's just the power rule applying to everything that's in parentheses. Okay, so let's move on to a few more challenging examples. All right, let's start by looking at A. A says 2a all raised to the third power. In case it's helpful, you can regard 2 as raised to the first power and a as raised to the first power. And now we're just going to take the power rule and apply it to each of these bases individually. Again, the power rule says write down your base and then multiply the exponents. So 1 times 3. Write down your base, a, and then multiply your exponents. 1 times 3. Let's simplify this. This is 2. 1 times 3 is just 3. And then a, 1 times 3 is just 3. 2 to the third is the same as 2 times 2 times 2, which we should know is 8. A to the third. Okay? Again, we're just applying the power rule to everything that's in parentheses. Let's look at B real quick. All right, so as we can see, we have 6x to the third squared. In this case, we know that the expanded power rule says apply this squared to everything that's in parentheses via the power rule itself. And according to the power rule, we're going to take 6, which is technically raised to the first. We're going to write its base, and then we're going to multiply these exponents, namely 1 times 2. And then again, according to the power rule, we're going to start by writing down our base, which is x, and then we're going to multiply these exponents. 6, 1 times 2 is just 2, so that's 6 squared. X, 2 times 3 is 6. 6 squared is 36x to the 6th. Again, it's just the power rule applying to everything inside parentheses. All right, let's look at C. All right, so we have x squared over y to the 4th. Okay, so again, if it's helpful, put that imaginary 1 there. Again, according to the expanded power rule, we're going to apply this 4 via the power rule itself to just this base of x as well as this base of y individually. So let's start with the x. According to the power rule, we start by writing down the base, which is x. Then we multiply the exponents, so this is going to be 2 times 4. Again, now we're going to apply the power rule to the base of y, so we're going to start by writing down its base of y, and then according to the power rule, we multiply the exponents, so this is 1 times 4. X, 2 times 4 is x to the 8th, and then y, 1 times 4 is y to the 4th. Okay, so let's go ahead and do D now. As you can see, there's a lot going on in D, but it's not that difficult. We have 2x over 3y squared, all raised to the third power. In light of the fact that this is powers raised to another power, we know we're going to use the power rule. And as needed, let's write our 1s accordingly. Okay, and now we're just going to apply the power rule to everything inside parentheses individually. So according to the power rule, we write down the base. In this case, the base is 2. Power rule says multiply exponents, so that's going to be 1 times 3. Let's apply the power rule to x now. Write down the base x, multiply the exponents, 1 times 3. Now let's apply to the power rule to the denominator, starting by writing down the base of 3. According to the power rule, you multiply the exponents 1 times 3. And then let's finish with the variable y. Write down the base y, multiply the exponents, 2 times 3. This becomes, now let's simplify this. It's going to be pretty straightforward to do. 2 to the 1 times 3 is 2 to the third. X to the 1 times 3 is x to the third. 3 to the 1 times 3 is 3 to the third. And then y to the 2 times 3 is y to the sixth. Let's simplify where we can. This is going to be 2 to the third, which is 2 times 2 times 2, which is 8, x cubed, over 3 cubed, which is 3 times 3 times 3, which is 27, y to the sixth. Okay, that's that one. All right, let me erase this and we'll talk about the sixth and final law of exponents, or exponent rules, however you want to refer to those. And then after that, we'll do a bunch of examples of these. And just bear in mind that I know I'm devoting a whole video to this. Here's the thing about the ASVAB. When you take the ASVAB, you're probably going to see 1 or 2 questions per video that I create. So just keep that in mind. All right, number 6, or the sixth law of exponents, is in regard to negative exponents. It says if a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So in this case, we have x to the negative m. To write that as positive m, you simply shift it into the denominator. Again, it went from this, x, and I went back to the thick pen. Let me go back to the thin pen. This is x to the negative m over 1. And again, as you deal with these exponents, you're typically not permitted to leave negative exponents in the numerator. In light of the fact you have to know that you can use the negative law of exponents to simply just shift this into the denominator and it will be positive. So in this case, it's going to cross this fraction bar and it's just going to become positive. So that's all that says. Those two are the same. Okay, similarly, if you want to go from the denominator with a negative, that's going to prompt you to put the variable x and the numerator with a positive m. Okay, so that's all there is to that. Again, in this case, we have everything raised to the negative n. And let me expand this one since it's not that clear. We have x over y, all raised to the negative n. Again, remember, there's technically a negative 1 there and a 1 there. And we know via the expanded power rule that this negative n is going to apply to both x and y individually. And it's going to do so via just the power rule. So let's go ahead and work this out. Again, power rule says write your base first. This is x. Then we're going to multiply the exponent. So this is going to be 1 times negative n. And then write down the base, y. And then multiply the exponents, 1 times negative n. Okay, so this becomes x to the negative n over y to the negative n. And as I mentioned, you cannot leave negative exponents in your work. So in light of that, we have to know that this negative is just going to shift this x across the fraction bar where it's going to be positive. So that's going to be x to the n. And it's going to do the same thing to the y. It's going to take this y to the negative n and shift it to the numerator where it's going to be positive. So again, If you shift things across the fraction bar, it changes the sign from negative to positive and vice versa. In this case, we went from x to the negative n in the numerator, brought it across the fraction bar where it became x to the positive n. In this case, we had y to the negative n in the denominator. We shifted it across the fraction bar where it became y to the n. Okay, so that's what the negative exponent law says. So let's go ahead and take a look at a few examples of that to get some practice. All right, so for question A, we have x to the negative third. Again, as I mentioned, you cannot leave your answer in this form. But that said, we have to be mindful that if we shift this across the fraction bar, this is technically over 1, that will become positive. So this will be 1 over x to the third. Okay, let's look at B. We have 4 to the negative 2. Again, we can't leave it like that, but that said, we know if we shift it across the fraction bar, it's going to be positive. So this is going to be 1 over 4 squared. Let's look at C. And we got negative 4 x to the fifth y squared. Y to the negative squared. Okay? So negative 4 can stay. X to the fifth can stay. It's positive. But we can't leave this y to the negative squared in the numerator. And in light of that, we're going to have to shift it across the fraction bar into the denominator where it's going to become positive. So we're going to leave negative 4x to the fifth. There's nothing wrong with that. And then again, we can't leave this as a negative with a negative exponent. So that's going to prompt us to bring it across this fraction bar where it's now going to become just y squared. Okay, so that's all there is to dealing with these negative exponents. Again, if it's negative, bring it across the fraction bar, it will become positive. All right, let's see. I think they give us a few more examples of these to do. All right, good. Let's do D and F now. And I keep going back to the thick pen. I don't know why. All right, so let's go to D. As we can see, we have x squared y all to the negative third power. Okay? And again, if it's helpful, we can go ahead and write this as to the first power. And so before we begin, we have to recognize what we have going on in this problem. As you can see, we have everything inside the parentheses raised to the negative third power. So the first thing I'm going to do is use the expanded power rule to apply this negative 3 to this base of x as well as y individually. And that's going to look like this. Again, according to the power rule, you write down the base first. So we're going to just write down x. Then you multiply the exponents. So that's going to be 2 times negative 3. All right. And then we're going to do the same thing to the y base, which is going to be y. And we're going to now multiply the exponents according to the power rule. So that's going to be y to the first times negative 3. Let's simplify this. This becomes x. 2 times negative 3 is negative 6. And y, 1 times negative 3 becomes y to the negative third. As I said, you cannot leave negatives in your answer. In order to get rid of negatives, you simply bring it across the fraction bar. So let's do this one at a time. To make y to the negative third positive, we're going to bring it up across the fraction bar into the numerator, where it's just going to be y to the third. And to make x to the negative 6 positive, we're going to have to drop it down across the fraction bar, where it's going to become x to the 6th. Okay, so in this case, we had to apply first the expanded power rule, then the power rule, and then we had to address the negative powers. Okay, so nothing too difficult, just a lot going on. And this is about, I'm going to say D and F is about the level of difficulty you should expect to deal with on the ASVAB. Of course, that's depending on how you're doing. Again, it's a computer adaptive test, so if you're doing well, you might see something that's slightly harder. And if you're doing poorly, you might see something that's slightly easier. Let's take a look at F now. This is A to the -2, B to the 3rd, C to the -4th, D to the -1st. So at first glance, you have to say to yourself, what do I have going on here? And again, as I mentioned, you cannot leave negative exponents in your answer. So we're going to have to shift some things across the fraction bar to simplify this. As we can see, B to the 3rd is positive, so we know we're not doing anything with that. That can stay. A to the -2. Again, it can't be negative in the exponent, so that's going to prompt us to shift it across the fraction bar where it's going to become positive. Okay. Similarly, this C to the -4th, we can't leave it as it is, can't leave a negative exponent in place. And to get rid of it, you simply shift it across the fraction bar where it becomes C to the 4th. And as you can see, by shifting it across this fraction bar, it went from negative to positive. Okay. Same with D to the -1st. We can't leave that in the answer. We have to shift it across the fraction bar where it becomes D to the 1st. And now let's clean this up. Again, we have C to the 4th, D. Again, D to the 1st is just D, so we're going to drop that one exponent in our simplified answer. B to the 3rd over A squared. Okay, so that's all there is to this one. And they order these B, C, D. It makes no difference how you order those. Let's take a look at E now, E and G, and then we'll get to some real practice problems. E says parentheses 3x to the -2, y -2 x, y -3. So again, it's always a good idea to have a plan of attack as you look at these. So you want to talk yourself through it so you know exactly what laws of exponents are going to come into play as you're dealing with this one. In this case, you can see that there's no power rule in play. Again, this is this one times this one. So we're going to be using the product rule. And unlike the power rule, that means we're going to add exponents. So let's start simplifying this one, and bear in mind that we're using the product rule, not the power rule. Again, the power rule would be if this was raised to the 3rd. Product rule is when you multiply exponents together that have the same basis. So let's start by doing 3 times -2. 3 times -2 is -6. All right, and let me go back to the small pen. I keep grabbing the big pen. Sorry about that. All right, so that's taken care of. That's just basic arithmetic there. Whole number times whole number. All right, so now we're going to apply the product rule to x to the -2 times x. Again, technically there's a 1 there. X to the 1st. In case you forgot already, the product rule says write down the base, and then instead of multiplying the exponents, you simply add them. So this is -2 plus 1. So we've taken care of the x's. Now we're going to use the product rule to deal with the y's. Again, according to the product rule, you write down the base. That's going to be y, and technically this is to the 1st here. And then you add the exponent, so this is going to be y minus 3. Okay, so now let's simplify this. Again, this is -6. X, -2 plus 1 is -1. Y, 1 minus 3 is -2. We can leave -6 as it is. That's no problem there. because again, this is raised to the first power, so that's no big deal. But let me get rid of that real quick. Again, if it's raised to the first, you typically don't express it. But we do have, as you can see, x to the negative first and y to the negative squared. We can't leave it like that, so we're going to have to bring it across the fraction bar where it's going to become positive. So this is going to be x to the first y squared. Okay, and again, shifting it across the fraction bar prompted its sign to change from negative to positive. All right, let's go ahead and do G, and then we'll move on to the practice problems where we'll have to apply all of these laws of exponents to solve a couple of problems. All right, let's look at G now. We have negative 2x squared, y to the negative fourth, all negative squared. So in this case, you can see that we have this negative squared, which is going to apply to everything inside parentheses via the power rule. Okay? So again, we're going to apply as our first step this negative 2 to everything inside parentheses. And if it's helpful, I'm going to write a 1 there. Okay, so this is going to be negative 2 as our first base. And then according to the power rule, we take this exponent and multiply it by this exponent. So that's going to be 1 times negative 2. All right. Again, according to the power rule, we write down our next base. And then we apply multiplication to the exponent. So that's going to be 2 times negative 2. And then, again, we're going to finish with the last base of y. According to the power rule, we multiply negative 4 times negative 2. So this is negative 4 times negative 2. Let's start simplifying. This becomes negative 2 to the negative 2. This becomes x. 2 times negative 2 is negative 4. Y. Negative 4 times negative 2 is positive 8. Again, a negative times a negative is a positive. So as you can see, we got to shift a couple of these bases across the division bar to prompt their exponent to become positive. Let's start with 2. And again, I'm just going to write my division bar to make things easy. Let's start with 2. Again, we want this negative 2 exponent to be positive. In order to do that, we're going to have to shift it into the denominator where it's just going to become a negative 2 squared. Let me redo that real quick. And then similarly, with this x to the negative 4, we can't leave it like that, so we have to shift it across the fraction bar into the denominator where it's just going to be x to the 4th. And then, as you can see, y to the 8th is fine. We can leave that as is. Don't have to shift it. All right. And just one other thing. We have to be mindful that this, and I should have been clearer about this, this is technically like that, which means that this square is going to apply to the negative as well. So this is going to be y to the 8th over negative 2 squared is the same as negative 2 times negative 2, which is going to be 4x to the 4th. Okay, so that's my bad. I didn't include the parentheses as I did that, but we'll see more examples. So, all right, so that was that one. Now let's go ahead and move on to the practice problems where we're going to have to apply all of these laws of exponents at once, which is not too bad, as you've seen. And here's what I should have mentioned because I made this mistake. If something in the parentheses is squared, that means you include the negative. If, however, and let me write this out. If the negative is inside the parentheses and it's squared, you include the negative when you square it. So this becomes negative 3 times negative 3 is 9. That said, if it's written like this, where there is no parentheses, again, this is the same as -1 times 3 squared. So this is the same as -1, 3 times 3, which is the same as -1 times 9, which is -9. So again, be mindful of the fact that negatives inside the parentheses go along with the whole number, whereas if it's outside the parentheses, technically there's a -1 hanging out in front of the whole number, which means that you do not take that negative into account when you square it. Okay, you kind of leave it out in front and apply it after you're done doing the square. And I made that mistake right here in G, so as you saw. All right, so with all that said, let's get to these practice problems. And I think we're going to do every other one since we've done quite a few. We're going to do the odds since we've done quite a few examples already. All right. Let's go ahead and get started. Again, we're just doing the odds in this video. Otherwise, it would probably be 2 hours long. So number 1, and I'm going to use my blank sheet of paper off to the side to do the work. For number 1, we have 3 times 4 to the third. Again, you might be tempted to use the product rule, but again, the product rule only applies when the bases are the same. So we can't add 3 to the first plus 4 plus 3. We can't do that. That said, we can simplify this one by simply working it out. 3 to the first is just 3. 4 to the third is going to be 4 times 4 times 4. This is 16 times 4, which is going to be 64. And in case you need me to work that out, I will. 4 times 6 is 24, carry your 2. 4 times 1 is 4, plus 2 is 6. And again, now this is 3 times 64, which is just multiplication, which we can do. So this is 64 times 3. 4 times 3 is 12, carry your 1. 6 times 3 is 18, 19. So this first one is 192. We didn't use any of the laws of exponents. We simply worked out these exponents. Okay, so just be mindful of that. In order to apply the laws of exponents, the bases must be the same. And let's go ahead and see how many are in this column. All right, so let's move on to number 3. It's x to the 5th times x to the 3rd. As I said, it's always helpful to have a game plan. So in light of that, we should recognize that we can apply the product rule in this case because we have the same base of x, which is going to prompt us to start by writing down the base. And then the product rule says add the exponents. So this is 5 plus 3, which is the same as x to the 8th. All right, let's move on to number 5. We have 6 to the 5th over 6 to the 3rd. So as we look at this problem, we should be saying, what law of exponent can I use? Well, the bases are the same in this case, 6 and 6. So we can apply the quotient rule in this case. To use the quotient rule, you write down the base to start, and then you, instead of adding the exponents, you subtract them. So this is 6, 5 minus 3, which is the same as 6 squared, which is the same as 36. All right, let's move on to 7. This is 8 to the 0 power. Again, according to that law of exponent, anything excluding 0 that's raised to the 0 power is just 1. So that's that one. All right, let's move on to 9. We have y to the 4th cubed. Now we're going to have to apply the product rule. no, not the product rule, the power rule to solve this one. Again, this was the product rule right here when you're multiplying bases that are the same. In this case, we're taking the base of y to the fourth and raising it all to the third. So we're going to apply the power rule, which says write down your base to start and then multiply the exponent. So that's going to be 4 times 3, which is going to be y to the 12th. Okay, let's move on to number 11. All right, so let's copy it down. And again, at this point, you know enough about the laws of exponents to attempt these problems on your own. So if you're following along, it's a good idea to pause the video, try to work out these problems on your own, and then resume playing the video to see if you and I came up with the same answer. So this one is 6x to the 7th, 2x to the 4th. Let's start by simplifying it. In this case, we have to be mindful that we're going to apply the quotient rule because we have x and x as our base and its division, so that's going to prompt us to subtract those exponents. But first, let's simplify this fraction. 6 divided by 2 is the same as 3. All right. And as I said, here we can apply the quotient rule, which says write down your base first and then subtract the exponent. So this is 7 minus 4. And then we're going to have 3x. 7 minus 4 is 3. All right, let's go ahead and do number 13. And let's be careful to copy down this one correctly. Since there's a lot going on, we have 2c d to the 4th squared times c d. That's a bad d. Let's fix that real quick. C d to the 5th. Okay, so as I said, it's a good idea to have a plan of attack as you deal with these problems. For this one, here's my plan of attack. I'm going to use the expanded power rule to apply this squared to everything in this parentheses first, and then I'm going to use this expanded power rule to apply this 5 to everything in this parentheses after that. And then, as you can see, I have all of this in parentheses times all of this, which is going to prompt me to finish this problem by using the product rule. Okay, so again, even as you work with exponents, the order of operations is still in play. And as you can see, we're working on, there's nothing to simplify in parentheses, so we can't do anything in parentheses. That said, we do have these exponents hanging outside the parentheses, so we're going to work on that first. Then, as you can see, once we do that, we'll still have this multiplication to do. Okay, so again, we're going to do exponents first, multiplication next, which is in accordance with the order of operations. So in light of that, let's go ahead and get started. I'm going to do these one at a time so as not to skip any steps. Again, let's go ahead and wherever there's no power expressed, let's put a 1, just so it makes our work a little bit easier in the long run. Again, anything raised to the first power is itself. To the first power is just 2. All right, so let's apply that. That's going to be, and again, I'm going to keep everything in parentheses to keep my work nice and neat. So again, we're using the power rule to do this. This is going to be 2, and according to the power rule, you write down your base first, except that looks like a z. This is a 2, and you do 1 times 2, okay? And then you do c, write down your base, 1 times 2. D, write down your base, 4 times 2. All right, so we've taken care of this exponent now. Let's work on the other one. Again, according to the power rule, you write down your base, then you multiply the exponent, so this is 1 times 5. And then similarly, you write down your base and multiply the exponents, 1 times 5. All right, let's simplify what's in parentheses before we move on. 2 to the 1 times 2 is 2 squared. C, 1 times 2 is just 2. D, 4 times 2 is 8. All right, let's move on here. This is C. 1 times 5 is 5. D, 1 times 5 is 5. Okay, so we've dealt with our exponents. Now, in order to do this multiplication between these variables here, we're going to have to make use of the product rule, which again says if the bases are the same and you're multiplying it by something with another base, you simply add the exponents. As we can see, there's nothing by which we're multiplying 2, so that's just going to be 2 squared. But that said, we have c squared times c to the 5th. Okay, so that's going to become, according to the product rule, c 2 plus 5. And then again, we're going to use the product rule to do d to the 8th times d to the 5th, which is going to become d 8 plus 5. Now we can simplify this. 2 squared is 4. C, 2 plus 5 is 7. D, 8 plus 5, 8, 9, 10, 11, 12, 13. Okay, so that was that one. Pretty challenging. Again, we did the power rule twice for each of these inside the parentheses. Then we did the product rule to combine those via multiplication. So that was that one. Let me go ahead and clear off this blank paper, and then we'll move on to the next series of practice problems, and we'll almost be done. All right, so let's go ahead and move on to the next row. All right, 15 says x to the 5th, y to the 6th. That's all over x, y squared. All right, so again, let's come up with a plan of attack. In this case, we should realize that we're going to make use of the quotient rule, which is this. We're going to write down our base of x. And then since we have a base in the numerator as well as the denominator, which is technically raised to the first, we're just going to subtract our exponent. So this is going to be 5 minus 1. And then we're going to do the same thing with y. We're going to write down the base y, 6 minus 2. Let's simplify. X to the 5 minus 1 is 4. Y to the 6 minus 2 is 4. Okay, so that was that one. Let's move on to 17. Let's go ahead and start by writing it down. This is going to be 4x to the 5th, y over 16x y to the 4th, all raised to the 3rd power. Okay, so clearly we can see that we're going to be applying the expanded power rule to apply this power of 3 via the power rule to everything inside parentheses. Similarly, we should notice that we're going to use the quotient rule to simplify x to the 5th over x, y divided by y to the 4th. That said, we have to figure out an order in which we're going to work this out. Thankfully, we know what the order of operations are. That's please excuse my dear Aunt Sally, which is going to help guide our work through this one. We do what's in parentheses first, exponents next, multiplication and division from left to right, addition and subtraction from left to right. And as we can see, before we get to this exponent via the expanded power rule, we can actually simplify what's in parentheses via the quotient rule. So we're going to do what's in parentheses first. All right, so first I'm going to start by reducing 4 over 16 to simply 1/4. Again, 4 goes into 4 one time, 4 goes into 16 4 times. Okay. Now via the quotient rule, we can simplify x to the 5th over x to the 1st. And again, technically there are 1s there. Again, according to the quotient rule, you write down your base, and then you subtract the exponent. So this is 5 minus 1. We're going to apply this to the y as the base of y as well. This is going to be y 1 minus 4. And let's not get sloppy. This is all raised to the 3rd power. All right, so let's keep reducing this as much as possible before we apply that exponent. X to the 5 minus 1 is x to the 4th, and then y to the 1 minus 4 is y to the negative 3rd. As I mentioned previously, we can't leave negatives in the exponents, and to get rid of them, we have to shift them across the fraction bar. So in this case, let's copy everything else down. X to the 4th can stay, its exponent's positive. To make this y to the negative 3rd, y just to the 3rd, and we shift it across this fraction bar where it's going to become y to the positive 3rd. Again, these are both raised to the 3rd power. So now let's go ahead and apply the expanded power rule to everything inside parentheses. Again, this is, if it's helpful, write your 1s right there. Okay, so let's go ahead and do that. Again, the expanded power rule says use the power rule to apply this power to everything inside parentheses. So this is going to be 1 times 3, x, 4 times 3, 4, 1 times 3, and then y, 3 times 3. Oh, thinking ahead there. So we just got rid of that exponent via the expanded power rule. So now let's just simplify. 1 raised to any power is just 1, so we'll write that as just 1. X to the 4 times 3 is x to the 12th. 4 to the 3rd, or 4 to the 1 times 3 is 4 to the 3rd. Y to the 3 times 3 is y to the 9th. All right, so let's keep simplifying this as much as possible. And let's do it over here. Anything times 1 is itself. We're just going to drop that 1 out of the numerator. This is going to be x to the 12th over 4 to the 3rd, which is the same as 4 times 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. I think we saw this already. So this is 64 y to the 9th. And then there it is in simplest form. Okay, so that one took quite a few steps, but nothing was too difficult. We just used the laws of exponents as well as the order of operations to do things as they presented themselves. Okay. Hopefully the next few are easier. I think they are. That said, let's move on to 19. 19 says y to the negative 7th. All right, so as I mentioned, you cannot leave your exponent with a negative in it. To make it positive, you simply shift it across the fraction bar. So this is going to be y over, or 1 over y to the 7th. Let's go ahead and move on to 21. All right, 21 says 1 over x to the negative 5. Again, you cannot leave your exponent with a negative. In this case, we can't let x be raised to the negative 5. In order to make it positive, we're going to have to shift it across the fraction bar into the numerator, which is going to become x to the 5. And that's pretty much it there. Again, you could put a 1 over this to leave it in fraction form, but anything divided by 1 is itself. So we don't have to do that. And we're going to need some space to do 23. So let's get out the old eraser here. Get rid of this. Glad that one's over. All right, so let's do we have room down here? Yeah, we do. Let's do 23 and 25 down here. 23 says x to the 5th times x to the negative 1st. So again, this is going back to the product rule. We have base x times something also to base x. So according to the product rule, you write down the base x and then simply add their exponents. So this is 5 plus negative 1, which is the same as 5 minus 1, which is just going to be 4. So this is x to the 4th. All right, let's move on to 25. 25 is x to the 9th times x to the negative 7th. Again, as we did above, we know we're going to be using the product rule since we have everything base x. So that's going to prompt us to write down the base and then add the exponents. This is 9 plus negative 7, which is the same as 9 minus 7, 7, 8, 9. So this is x squared. Okay. All right, so let's erase this and then move on to the third column, and then I think that will be enough practice for today. And I don't think we're going to do all the problems in the third column because toward the end, this worksheet gets a little ridiculous in my opinion. Again, if you've followed along so far, you'll be in good shape on the ASVAB. So we're going to cut this off at question 33. So let's put a little mark there. Again, most YouTubers give you one practice problem. I'm doing like 30 in this video, so. 27, we have x to the negative 1st over x to the negative 8th. All right, so we can see that we have a few options as to what we can do to solve this one. We can either shift the exponents first and then apply the quotient rule, or we can just do the quotient rule and then apply the negative exponent rule. I'm going to go ahead and rewrite this using the negative exponent rule. So x to the negative 8, we can't leave that negative as an exponent, so we're going to have to shift it across this fraction bar, which is going to cause it to be x to the 8th. And similarly, we can't leave negative 1 as the exponent over here, so we're going to have to shift it across the fraction bar to make it x to the 1. Now, as you can see, we can use the quotient rule to solve this one. More specifically, that's going to be x 8 minus 1, which is the same as x to the 7th. Okay, 29. We have f to the negative 3 times f squared times f to the negative 3. Again, this is just multiple iterations of the product rule. So in light of that, we're going to just take them one at a time. So to start, I'm going to do, well, we can actually do them all at once. It's not that big of a deal. So according to the product rule, when you have things that are to the same base, you simply add their powers. So this becomes f, and we're going to add the powers. Negative 3 plus 2 minus 3. Simplify, negative 3 and negative 3 is negative 6, plus 2 is negative 4. As we can see, this all simplified to f to the negative 4. As I keep mentioning, we can't leave negatives in the exponents, and in order to make them positive, we have to shift them across the fraction bar. So in this case, this is going to become 1f to the 4th. Okay, so that was that one. Let's do 31. 31 is 24x to the 6th over 12x to the negative 8th. Now, at this point, you do have options as to what you can do. Again, we can't leave things with negative exponents. So the first thing I'm going to do before I do anything else is get rid of this negative exponent. So more specifically, I'm going to take it and shift it across this fraction bar into the numerator, which is going to make it x to the 8th. Okay, so now let's simplify things. The next easiest thing to simplify is 24 divided by 12. We know that's 2. Again, this is x to the 6th, x to the 8th. And this says 2 x to the 6th times x to the 8th, which is going to be the product rule. So this is 2x 6 plus 8. Again, according to the product rule, you add the exponents. 2x 8 plus 6 is 14. Okay, so that was that one. And let's do the final problem in this video. Let's make sure I copy it down right. 2x 3 y negative 3 negative 2. Okay, so all right, so we need to come up with a plan of attack. In this case, we can see that we have a negative exponent, which is a no-no. And we have everything raised to the negative 2 power. I'm going to work this one out in my way. There's multiple ways to actually work this one out. But first, I'm going to rewrite this inside parentheses in order to make it easier to understand. So this is going to be 2x to the 3rd. And as I said, I'm going to get rid of this negative 3 by shifting it into the denominator and across the fraction bar, which is going to cause its negative exponent to become positive, and that's all to the negative 2nd power. Now I'm going to use the power rule to apply this negative 2 to everything inside parentheses. So this is going to be 2 to the negative 2, x to the 3 times negative 2 over y to the 3 times negative 2. All right, so now we're just going to simplify. This is 2 to the negative 2, which is 2 to the negative... it's 2 to the negative 2. And as I said, we can't leave negatives in the exponents. So in order to make this negative 2 positive, we're going to shift it down into the denominator, which is going to become 2 squared. In this case, we have x. 3 times negative 2 is negative 6. And down here we have y. 3 times negative 2, which is y negative 6. Again, that's all in parentheses. That said, we now have more exponents that are negative that we have to shift across the fraction bar to make positive. So that's going to be, and let's work this out real quick. 2 squared is just 4. Let's deal with that. Again, let's move this y to the negative 6 into the numerator to make its exponent positive. And similarly, let's shift x to the negative 6 into the denominator to make its exponent positive. So the final answer to this one, which we can drop the parentheses for now, is y to the 6th over 4x to the 6th. Okay, and as I said, we're going to stop right there. I hope you found this video helpful. Admittedly, this is a pretty lengthy video, and we covered quite a bit of ground. We covered all the rules or laws of exponents. Again, you will see some questions in which you have to deal with the laws of exponents on the ASVAB for sure. So make sure that you have a good understanding of these laws of exponents. If you like the content I'm creating, by all means, go ahead and subscribe to my channel. By the end of July, I anticipate having videos for every topic that's going to appear on the Arithmetic, Reasoning, and Mathematics Knowledge Subtest. In addition, I'll keep creating practice tests for those subtests as well as the Word Knowledge Subtest. As far as the Word Knowledge Subtest goes, I anticipate having between 500 to 1,000 common vocabulary words for you to study with. So all that said, hope you enjoyed the video. Leave some feedback in the comment section below if you desire to do so. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.